What's up, everybody? This is question 1 from the chapter 9 through 10 free response, so let's just dive right in. On the first question here, we're given a position function x equals 0.5 t cubed plus 2t. So we know that speed or velocity is equal to the derivative of position, all right? So we just want to take the derivative of the function that's given to us. So we're going to take d dt of 0.5 t cubed plus 2t. So that's just the power rule there. We get 1.5 t squared plus 2. And the question is, determine the speed of the box at time equal to 0. So then we just plug in 0 for t. So v of 0 is equal to 1.5 times 0 squared plus 2. So we get that the velocity at 0 is 2 meters per second. All right. Now we need to determine the following as functions of time t. So the kinetic energy of the box. Well, here's what we know. We know that kinetic energy is equal to 1/2 mv squared. Well, we're given a mass in the problem. So in the problem, it says the mass is 100 kilograms, and then we just got a function for velocity right here. So let's just plug those things in. I can get k is equal to 1/2 times 100 times 1.5 t squared plus 2 squared. So really, you can just simplify this down to 50 times 1.5 t squared plus 2 squared. And that's enough for this problem. So that's what we get for the kinetic energy, 50 times 1.5 t squared plus 2 squared. Don't forget the squared on the velocity. This right here is really easy to forget because you already write a squared value within the velocity function, so don't forget to apply it to the entire thing. Now for the net force acting on the box. Remember, the thing that connects force and kinematics is acceleration. So we need to figure out how to get acceleration from the information that we have. And we know that acceleration is equal to the derivative of velocity. So I'm just going to take the derivative of the velocity function that I got from the position function, which is 1.5 t squared plus 2. So I get that the acceleration function is equal to 3t. I know that net force is equal to mass times acceleration. Well, my mass is 100 kilograms times my acceleration function. So I get that my net force is 300t. All right. Moving on. So let's talk about power, the power being delivered to the box here. There are like two ways that you could have done this here. Let's talk about the easiest one first. So broadly, power is represented by the dot product of force and velocity. We have a force function, we have a velocity function. So let's multiply them. Power is equal to 300t times 1.5 t squared plus 2. So I get that the power is equal to 450 t cubed plus 600t. So that's method 1 to figuring that one out. The other way that you could have done this is that power is equal to the change of kinetic energy per time, so the derivative of the kinetic energy per time. So then I just use my kinetic energy function that I got, which was 50 times 1.5 t squared plus 2 squared. And when I take the derivative of that, again, I get 450 t cubed plus 600t. All right. Now, I haven't really talked about points at all yet, but on this one, this was a total of 2 points. 1 point came from just writing the function that you were going to use. So either one of these would have gotten 1 point, and then you got 1 point for the correct answer. All right. Remember, it's very important that you write those equations down as you go. All right, let's talk about C. Again, we have 2 ways of solving this one. I'll talk about both. So on C, the first way that I'll go over is work is equal to the change of kinetic energy. All right. Or net work is equal to change of kinetic energy. That's that network change of kinetic energy theorem. So here, I can say that work is equal to 1/2 m times v final squared minus v initial squared. Now, I need to figure out what this v final is going to be. So this is going to be v of 2. This is going to be v of 0, which I've already determined. So let's just plug these in. I get work is equal to 1/2 times 100. Now, v of 2, that's going to be 1.5 times 2 squared plus 2. V of 0, that was 2, so then this is going to be minus 2 squared. So I'm going to get that the work is equal to 3,000 joules. All right. Another way that you could have done this, and this is a definition that's on your equation sheet, is that work is equal to the integral of power with respect to time. So then all you're going to do here is plug in your function for power. Work is equal to the integral from 0 to 2 of 450 t cubed plus 600 t. So the work is going to be, this is going to change to 450 over 4 t to the 4th from 0 to 2 plus 600 over 2 t squared from 0 to 2, which will give us 1,800 joules plus 1,200 joules, which again gives us a net work of 3,000 joules. So 2 ways of doing that one. Where your points came from on here, it was 4 points total. You got 2 points for one of these statements of how you were going to solve for the work. Then you got 1 point for determining the velocity at 2, and then you got 1 point for the answer. Over here, you got 1 or 2 points for plugging in your power function. You got 1 point for stating this, and then 1 point for the answer. All right. Finally, part D, we would want to select greater than here, and the rationale for that. The work done by the student is equal to the change of kinetic energy plus the work done by friction. All right. So the student has to perform work against this friction force, and that's why it's going to be greater than. And on this one, we had 2 points total, 1 point for that answer, and then 1 point for the correct justification. All right, guys. Hopefully that helped.